書籍は毎回このものですかね。今日は何かあった。なんかあるかもね。Okay, for the attending, so you can go to the web. So today I will using the web class to get your attendance. Go to here, click here, the top, and oh, sorry, let me log in as student. Attendance here, and this one, click this one, and then you use the password of this 0518 today's date, okay, to get your attendance, please. Somebody, I also like to ask you to also do that, okay?
Yeah, thanks. I got it.
Okay. So today is number 10. So from today, we are going to study nonlinear analysis, single degree freedom and multiple degree freedom. Okay. So, but before that, I hope you realize that there is assignment 3. Assignment 3 here, MDF model. So from the beginning, I will introduce you a little bit about this assignment. Okay, a little bit help of this assignment. Okay. Okay. Here is some supplement contents. You need to memo this equation right now. Take your note and memo this equation so that you can finish your homework. Because in mathematics lecture, these equations are not shown. But you are encouraged to derive this equation by yourself. But for the correct answer is here. Okay, so this is the correct answer. So when you use Rayleigh dumping, you will use a ratio of mass and ratio of K. So A0 and A1 is just a parameter, a ratio of mass and stiffness. What this equation means is that if the structure have larger mass, big structure, then dumping should be large. If the structure is very stiff, strong, means they have large cross sections, then they have larger dumping. Okay, so they are being influenced both by the mass of the structure and the stiffness of the structure, roughly. This is just a simple assumption, which is practiced well in the real world. Okay, so you need to memo this. So I didn't show this in any PowerPoint or any slide to you. So you need to memorize this right now to do your assignment 3. Okay. So sorry that you need to do this. So next year we will improve that. Okay. So why? So what is the problem? Is what is A0 and the A1? I think this equation mathematical science already explained this equation, right? But why? How to calculate A0 is A1? Is that you put it back to the equation of motion, right? On both sides, multiple their mode vector. Okay, both sides of the equation. Then you will get their mode mass, mode damping, and mode stiffness. And which mode is equals to 2h omega and the m, right? Mode damping. And with the first mode and second mode, it should be both the same result. And using these two equations, first and second mode, you can get A0 and A1 from these two equations. For the time saving, I will not explain how to derive the equation, but the result will be this. For the people who is just joining the room, please using the web class, there's a tendency here, tendency here and today's date, and you click it, use this date to as password to log in. Okay. I think before this you have another lecture, right? So okay. So you need to remember this equation. So you need to realize that the under part are the same. Under part, omega 2 square minus omega 1 square. This part are the same two equations. So you just calculate one and calculate both of them. But the upper part are different, right? Upper part different. So if you multiply this inside, it both start from 2, but this which is omega 1, omega 2 power h1, and omega 1 power omega 2 h2. Okay, but this one is only omega 2 h2, omega 1 h1. Yes. Okay. So this part are different. So you can calculate A0, A1, and then you can calculate C. You see, you can do your response analysis, which I'm going to explain from right now. Okay. So the beginning of the function, this time I need you to import one more library, which is NumPy linear algebra. From this import EIG, which is a function to calculate eigenvalue. You do the mode analysis. You calculate the mode frequency, angular frequency, omega. You need this, or you can write a program by yourself. It's also okay, but I think use this function will be far more faster, far more convenient. Okay, so use this firstly. You need that. The earthquake input, download earthquake. I didn't write download earthquake this part. I think download earthquake is here. Okay, so it's the same. It's the same as before. Okay? The single degree of freedom is before. Okay, I'll pass this part. So remember this equation, daily damping. Okay. For H1, H2, we simply H1 is the damping ratio for the first mode. H2 is damping ratio for the second mode. Generally, they are following some equations of that high frequency have a higher damping, low frequency have a lower damping. This is an equation, but simply here in this lecture, simply we just all take 0.05% for each time. For steel structure, actually it becomes 0.02. For some special structure, it becomes 0.05. But in most of the design spectrum, we use 0.05 thoroughly. So please use 0.05 here. It's a conservative value we can use. Yeah. And this part is you need to be. So you need to save your MDOF model and read your MDOF model. So which you decide MKH for each degree of freedom. So M is just a title. Under it, it have number 1, 2, 3, 4, 5. So I have mass under it. I have K under it. So for this homework, you do 3 degree of freedom, only 3, okay? M1, M2, M3. All of them equals 1. So K, 3 spring, K. K1, K2, K3. All of them equals 100. For H, you can write for each mode. For 3 degree of freedom, we have 3 modes. So each of them equals 0.05. You only use the first 2, but for the easy of coding, just every mode is 0.05. Okay. So you need to save this mode to a TXT file, and then write this one by one. Okay. So you define this, and you need to read this from the file. Okay. Open the data, split them, and read them one by one. Okay. Now you have the M, K, H in small letter, which means that the M, K, and dumping for M, K for each degree, each spring and each mass. And you have the H for each mode. Then you need to build the three matrix M, C, K, which is build matrix function doing. Okay, all matrix vectors in this program are using NumPy data, NumPy array. It has to be NumPy array. You cannot use in list. Okay, so we decide 0 for them in the beginning, and in the n multiple n dimension, n is equal to 3 in this homework assignment. Okay, omega n. Okay, you have 3 omega. T have 3. F you have 3. And you build M matrix. Here is just an example how to build them. Consider that each in the center of the for M is only the diagonal component. M1, M2, M3. It's very easy. For the K, you remember that the K matrix, then you should know that you should use II, KII equals each K, but also K1 plus 1. And the other KI, there should be plus another one. But when from the second line, you should have this one. Okay, plus K minus 1. Okay, so that is just a K matrix. Be careful. You need also. I will suggest you use inverse. K inverse. Okay, because K inverse is going to be used heavily because you will minus everything, right? So once you use the K inverse, will be very convenient. Also later you calculate the parameters, you also use inverse matrix. So calculate inverse matrix is using the algorithm of Newton's method to delete line by line, or RU substitution. But here we use NumPy algebra function to use inverse matrix. Okay. So remember, in here, in NumPy, in Python, you multiple matrix to matrix, you multiple matrix to vector, you will use this NumPy dot. Okay, so here we are calculating the MK matrix, which is M1, okay, here, okay, to get the eigenvalue, okay, a character matrix. So you first get this one by inverse matrix and use use NumPy dot to multiply K. You cannot use multiple marks to calculate K. It will be wrong. It will be, if you directly multiply them, it will be element wise, element to element, okay? Element to element multiplication. For matrix multiplication, you need dot this function. So all later calculation, you remember using dot. And you get this matrix, we call this matrix X, and you get eigen function we defined before. Use this, we get omega, which is eigenvalue, V, which is eigenvectors, all eigenvector. We don't use here, we don't use omega here. But actually, this is the omega square, so you should get a square root of omega. And then you get F here, and get them. But it was getting result with the largest number. But the first mode is the smallest frequency. Largest period is the main mode, first mode. So we get the -1 and -2, which is the last one and second last one of the omega, which is the first and second omega mode, omega. Okay. So the larger one will be getting out for the general eigenvalue, but right now we are using the smallest one and the second smallest one as omega 1, as omega 2. But if your omega is very, very large, then you are getting it wrong. So you should calculate it A0, A1 as we mentioned before and calculate the C matrix. You output this and print it out to see, check the first and second mode is right or not. You run this part. If you see your T is about 1.4, largest one, 1.4 is your T, right? First mode for 3 mode, then you are getting it right. If you get it a lot like 100, then you're getting it wrong. Okay, so T should be, largest T should be 1.4 second for first mode, okay? Okay. So let me give it a little bit recall of the equation motions you don't need to remember this. You just using the mathematics lectures slide will be fine. But here x2 dot I write as marked as A, and the x1 dot as V, and the x is D. It's incremental method, right? Here is the input earthquake, which is one vector. Each of them have only one vectors. Okay. Okay. Then incremental vectors, and Newton's method. I'm writing the summarized equation here just for your convenience to check it out. And until right now, mathematics are using the method based on displacement. You solve the displacement and get the velocity and acceleration. This equation is based on acceleration, so it will be shorter. The program will be shorter. The code will be easier. So I will put it here for your reference. You can use either this one, or you can use mathematics equations, or you can do them both. If you do both, I will give you some extra point. Yeah, that's right. This is actually just calculating some parameters. So M heart are 3 metrics, right? This one and this one and this one. And these are all constants, so you can directly multiply them. They're constants, the vector, they're not vectors, they're not tensor, so you can directly multiply to C and K matrix, beta and delta T squared, no problem. But pay attention here. Here, once you multiply this to one matrix, it'll be a vector. So vector multiple to a matrix, you use the matrix dot this one. Okay, this one, AA is a matrix. Use AA to multiple this one. This one, AV is a matrix. Use AV to multiple VN. Okay. These are constants, so you can get this easily, right? These are all vector multiple each other. They are same dimension tensor, then you can directly sum them together, no problem. Only in this part, be careful. Only in this part, you need dot, dot, dot. 3 dot to get it together. And solve this, you need M heart inverse. 2 dot delta F heart. Check the delta F heart is a vector, not a matrix when you do the calculation. Print the size, the shape of delta F heart. Then you can make sure that you are doing it right. Okay. So how they are doing it? So I'm showing it directly. Showing it is a init some empty matrix. Okay. NDOF from 0. NP. All are NP. Or NP. This is for storing the result. This is storing the result. And prepare some constant. Okay. Oh, I'm showing the correct code. Sorry, I should not showing this. Okay. Okay. This is the correct. Okay. So you need to do some calculation. Okay. So you need to calculate M heart AA AV, or using mathematical equation, you can have B, BV, BVD, BVA, or something. Okay. Remember, they are all metrics. They can sum them together. Okay, directly. So you output the result. Incremental step. what is incremental step is you calculate f hat, third f hat, using the inverse matrix of m hat and others, AAA, something. Then you calculate third A, or you calculate delta D like this, okay? Using dot, you calculate them. And then you calculate from third A to calculate third B, third D. Okay. X2 dot, X3 dot, or something like this. Imaginary, yeah, you're writing some code here. I'm not showing it to you. Okay. So these two empty block is only I keep it to you. Okay. Very easy to be wrong, but you need to be carefully try this. I will show you in the Newmark beta method, okay, how to do the Newmark beta method. So firstly, you will know the number of steps by the length of the wave. Remember that it should only do 3,000, not all of them. And prepare constants to do this functions before. Using the one to prepare the empty initiate calculation. And then do the step-by-step integration. With step-by-step integration, you get AG. And you get DAG from AG minus AN, okay? Then you give DAG to the functions, incremental step function, and they have more, okay? So for the single degree theorem, I will remember this incremental method again today, okay? And you get AVD. So last time you're calculating delta AV, delta AD, and delta D. So that is wrong. You need to calculate them to plus DN and BN and AN to get the, not from the incremental method to value to the step method. Record them and save them to the big matrix, and then return AVD, the result. You co-order them, and then you need some plot functions. I showed before. Okay. So if everything's correct, you should show like here. This time I show in the plot, in a subplot. N is 3 multiple 3. So each line you have displacement and velocity and acceleration, and for each floor. So you have n floors, right? So then plot them one by one by each of them. So for each degree freedom, you have the first one you have here A1, V1, and D1 here, and then A2, V2, D2 here, in all degree freedom. So if you have many floors, then you show this until here 100 floors, 100 of them here, okay? And save to files. So every result to the files. So when we run them, they will save the text file. So make sure that everything is written in the text file very well. So in the beginning, you have a head. For each line, right? AV, A1, V1, D1, A2, D2, A3, A3 there for each of them. So you have a first column should be times. Second column will be AG, the ground motion. And from the third one, it should be the AVD, AVD, AVD of the each floor, vertical there, okay? Wait, oh, you should like time, something under it, and AG. A1, B1, B1, and then A2, something, okay? It should look like this. Okay, so that is all for the for the assignment 3, okay?